Hello students, welcome to this session. Today we will be covering chapter 1, which is object oriented programming concepts, and these are the following topics which we'll be looking at: what is an object, what is a class, principles of object oriented programming, class as a user defined data type, message passing between objects. So today we'll be just covering what is an object, right? Okay, so first things first, what is an object? So everything around us is an object. Okay, everything, you can take anything. So for example, people, vehicles, buildings, streets, mobiles, televisions, you can name it. Okay, everything, each and everything around us, including ourselves, can be classified as objects. Okay, now you pick any object, that object will have some property, some attribute. Okay, like for example, take yourself, you'll have properties associated with you, attributes associated with you, like your name, your age, your gender. Okay, these are some of the examples of attributes. Okay, so every object will have some kind of attribute associated with it. Okay, and the other thing which an object will possess is the capability to perform some action. Okay, and for example, if we take the if you take a bird. Okay, so bird is an object. What kind of action can it perform? It can fly, it can dive, right? It can build nests, it can hunt. Okay, so these are the few examples for actions of a bird. Now whenever an object performs an action, okay, so that action will have some effect, at least on the object itself or on another object. Okay, or on both. Okay, so what do you mean, or what do I mean by an object's action having some effect on another object? So for example, if we take bird again into consideration, let's say the bird is building the bird is building a nest. Okay, so for building a nest, it will pick up straws from here and there, right? So straws themselves are objects, right? So when the bird object is acting on the straw object, okay, so the change is occurring in the straw, isn't it? What kind of change? Its position is changing. Okay, its position is changing. Previously the straw was somewhere else, but the bird has picked it up and taken it to the place where it has been building its nest. Okay, so that is what I mean by the statement that when an object performs some action, it will have some effect either on itself or on another object or on both. Okay, so I hope we are clear with this point here, and we need to remember this point, because this point we will be revisiting when we discuss message passing between objects. Okay, so this is an important point, please remember it. Okay, okay, next. So do we have just a single type of object? Actually we have two kinds of objects. Okay, tangible and intangible. Okay, And then we can further classify objects into roles and events. Okay, but mainly we have tangible and intangible. Okay, so tangible object means what? Tangible object means that's a object which can be seen and touched. Okay, that is tangible. Like for example, a computer is an object which can be touched, it can be seen. Okay, a piece of stone is an object because it's a piece of an object, tangible object, because it can be seen and touched. So there are many examples. Okay, you can think of a few examples yourselves. Okay. Right. So what are intangible objects? The second kind ones. Okay, intangible objects, they may or may not be seen. Okay, but definitely they cannot be touched. Okay, for example, email, bank account. Okay, so you can see your email. Okay, right, but you cannot touch it. Okay, similarly you cannot touch your bank account. Okay, you can perform some inquiry upon your bank account. Okay, you might be able to see it also, but you cannot touch it. So this is the example of intangible. Okay. Okay, so the next type of object is roles. Okay, so roles means what? Means it's a role played by certain objects. Okay, so for example, a teacher plays the role of teaching, a farmer plays the role of farming, a soldier plays the role of fighting, isn't it? So all objects, or at least some objects, will have some kind of roles associated with them. Okay, so this is known as roles. And the last one is events. Okay, so an event object. Okay, so what is an event object? An event object is something that occurs in a system or an organization. Okay, so for example, let's say you have a shop. Okay, and you are the shopkeeper. So and a customer comes to you. Okay, then you'll sell something, and the customer will buy something, right? So there is an event taking place. Two In fact, there are two events taking place. One is purchase and the other one is sale. So this is event based object. Okay, so I hope we are clear with tangible, intangible, roles and events type of objects. Okay, so these are just conceptual classifications. When we actually write code, will not be will not be writing different codes for these four these four types of objects. Okay, this is just for our understanding. Okay, it is not that for creating a tangible object you'll write one piece of code, and for intangible objects you'll write another piece of code. It's not like that. Okay, this point will become more clear when we come to the actual code. Okay, so don't worry about it. Okay, next. Okay, so now the most important point. Okay, you must be able to identify an object. Okay, the first thing, you must be able to identify an object, like what kind of object is it. Then you need to identify its attributes. Okay, and you also need to identify its behavior. As we discussed earlier, that every object will have certain action, right? So two things, attributes and behavior, you have to identify. Okay, so let's look at a few examples. Like in the previous slide, we saw the examples of people, vehicles, buildings, isn't it? So see, people, vehicles, buildings, streets, mobiles, televisions. These were the some of the examples. Now let's dive deeper into these examples, and let's find out what attributes and what actions these objects can perform. Okay. Okay. So just give me a minute. Okay. Okay. So here are the different kind of objects you can see. Okay. Let's see the first one. The first one, as you can see, it's a car. Okay. So it's a car. So type of the object is that it's a car, isn't it? What are the attributes associated with it? The attributes are name, model, weight, color, that is name of the car, model of the car, weight of the car, color of the car. Okay, so these are the properties or attributes. Remember, attributes associated with the car object. Okay, see the last column is having the actions that a car object can perform. Okay, so what kind of actions can it perform? You can see that it can the car can start, it can stop, it can drive, it can brake, it can reverse, it can go forward, it can go backwards. Okay, so there are many other actions belonging to the car object, but we have just listed out a few here. Okay, let's see the second example. In the second object, okay, the second object, you can see that there are peoples, right? So people, what kind of attributes are associated with people? You'll have name, age, address, educational qualification. Okay, so many kinds of attributes can be associated with people, isn't it? So these are the attributes related to people. Now what kind of actions they can perform? Again, there are many, but we have just listed out a few. The like singing, dancing, read, walk. Okay, so these are the examples of actions that people can perform. Okay, third object is buildings, isn't it? So buildings, what kind of attributes is associated with buildings? So number of floors, number of exits, color, the material with which the building is made. So these kind of attributes are associated with buildings, isn't it? And what kind of actions can a building perform? So look at the last column: close door, close window, lock main gate. The building can collapse, right? Change color, you can change the color of the building. Okay, so this is these are the actions that a building can perform. Okay, right. Let's look at the next example: streets. So streets, what kind of attributes are associated with a street? Width, length, material of which it is made, number of entries into the street. Okay, so these are just a few examples associated with a street. Okay, now look at the last column. That is the type of actions that a street can perform. The first action I've listed out is drain water, isn't it? When it rains, the street must be able to drain the water, okay, so that the water is not logged on the road. Okay, so drain water action. Then develop pothole. Okay, See, a street might develop a pothole, so that's a kind of action. Okay, then when a pothole occurs, the street can fix the potholes. Okay, so this is another kind of action that can be performed on the street. Okay, and last example I've given is accommodate cars. Okay, the street should accommodate cars. Okay, so these were a few examples related with streets. Okay, street actions. Okay, so up till here all the objects are tangible objects, isn't it? All the objects up till here, up till the streets examples, they are tangible. Now let's look at an example which is intangible object. Okay, so last one. Okay, bank accounts. Bank account is what? It's intangible. Okay, so the kind of attributes associated with a bank account are name of account holder, type, means account type, either it is salary account or savings account or current account. Okay, then the branch, then the gender of the account holder. So these are the kind of attributes associated with bank accounts. Now let's have a look at actions that can be performed by bank account. Okay, so withdraw, deposit, close account, open account, transfer money. So these are the options associated with actions for bank accounts object. Okay, so you should be able to clearly visualize and identify attributes. Okay, attributes and their actions. Okay, so let's go back. Okay, now, so why objects? Okay, why are we talking about objects? Okay, we are supposed to learn Java, isn't it? So how is object relevant to Java? Okay, so let's see why do we need objects. Okay, software Java, we are learning Java. That means our aim is to develop softwares in Java, right? Now what is a software? So software is basically when you take a real world problem. Okay, you take a real world problem and you come up, you devise a digital solution. Okay, you devise a digital solution for the problem. Okay, that digital solution can be performed by a computer. Okay, so again I'm repeating, software basically means taking real world problems and coming up with a solution, right? So if in real world we always deal with objects, so wouldn't it be best if we are somehow able to implement those objects directly into our code conceptually? Okay, so, because it will be easier for the client, for the person who needs the software, and for the person who will develop the software. It will be easier for the person to develop the software, and it will be easier for the client to explain his problem, his or her problem. Okay, so if in the future if you become a software engineer or a software developer, okay, and a client comes up to you with a problem, the first thing you'll, after analyzing the problem statement of the client, the first thing you'll do is identify the objects. Okay, identify the objects that are relevant to the client's problem. Okay, once you have identified the objects, then the next thing is you'll identify the attributes and behavior of the objects which you just analyzed. Okay, so that is why object plays a very important role while designing softwares. okay, especially in Java, okay, because Java is object oriented. Okay, now what are the components of an object? See, mainly we have three components, that is identity, state, and behavior. Okay, and the last one which you're seeing is attribute. Okay, attribute. It's not highlighted. The rest of them are highlighted, isn't it? So that's because attribute is related with state. Okay, attribute is not something independent. So that's why remember that we have three components. Okay, identity, state, and behavior. Okay, now identity means the name of a particular object. Okay, suppose if I have uh, two dogs in my house. Okay, so two dogs, both are dogs, but I'll have, let's say, one of the dog's name is doggy one, right? And the second dog's name is doggy two. Okay, so that is what is meant by identity. Okay, next is state. Okay, state. So if we have just taken an example of dog object. Okay, so let's understand what a state of a dog object might be. Okay, so state means the attributes. Okay, now see, state and attributes, I am correlating both of them. See, dog will have what kind of attributes? It can have gender, it can have breed, it can have um, color. Okay, is it hungry? So these are some of the examples of attributes related to a dog object. Okay, attribute. Notice that I'm using the word attribute. These are the attributes a dog object will possess. Okay, so what is the state then? Okay, so state means when you give certain values, when you associate certain values with the attributes. Okay, suppose name of the dog is doggy one, color of the dog is black. Okay, is it hungry? Yes. So you can see that I have associated doggy with name, doggy one with name. Is it hungry? I've associated yes value with it, right? And I've associated black value with its um, color attribute. Okay, so when you assign certain value to the attributes are known as states. Okay, so this is the relation between state and behavior. Okay, sorry, I mean this is the relation between state and attribute, not state and behavior. Okay, I'm sorry. Behavior. Okay, behavior. Okay, again, behavior means what? It's just set of actions that a dog or an object can perform. Okay, so I hope we are clear with this. Let's look at the next slide. Next slide is, what is an object? Okay, I've taken an example here. Okay, so I've taken an example of hammer object. Okay, so let's look at it. Okay, so first, see the first diagram. Okay, what is it showing? State. Okay, notice here, state. This is the state. And so state, you can see that it's written here, it's a grade 1 hammer. Okay, then it's a steel head. Okay, so these are the attributes. Okay, attributes or states related with the hammer object. Okay, behavior. Okay, the next this one. Okay, behavior. Okay, so you can see what will be the behavior or action that can be performed by a hammer. obviously pounding nails. Okay, so you can see in the diagram that the action is being performed is pounding. Okay, and lastly, the last diagram or the last block, you can see we have got identity. Okay, identity. So look carefully in the diagram. Okay, you can see that there are many hammers. All these are hammers. Okay, but each hammer that you can see, each hammer will have its own unique identity. Okay, each hammer is different from the other, although all of them are hammers, all of them are hammers, but still they will have their own unique identity. Okay, that identity which will distinguish one hammer with another. Let's say how can this be done? Let's say this hammer is hammer 1, this hammer is hammer 2, this hammer is hammer 3, this is hammer 4. See, like this. So when you give a name to an object, okay, that is known as identity. Okay, so I hope it's clear what is the meaning of identity, state and behavior. Okay, okay, now let's look at, yeah, let's look at the components which we discussed, like attributes, behaviors, and identity, how it is actually implemented in Java code. Okay, how it is implemented in Java code. You must be able to correlate whatever we have discussed so far in actual coding. Okay, not just theoretical understanding. You should be able to translate your concepts into code, right? So that is the final thing we are going to do for this session. Okay, okay, so let's take the example of student class. Okay, so you can see here that I have created a class called student. Okay, student class, right? This is student class. Inside the student class, you can see that I have got attributes here. Remember what kind of attributes a student can have? There are many attributes, but for keeping things simple, I've just taken two attributes, that is section of the student and age of the student. Okay, so string, section, int, age. Don't worry about the string and int now. Okay, just focus on section and age. So section will be storing the section in which the student is studying, and age will be storing the age of the student. So remember, this is what? This is attributes. Okay, and finally I have created two actions. Okay, so attributes you understood, right? How we can implement attributes in code. So this is how you can do. Now coming to behavior or action. Okay, identity, state and behavior. We have already seen state. Okay, now we'll look at behavior. Okay, so I've just used two examples. Student can study, student can write exam. Okay, so these are the kind of actions a student can perform. Okay, so these are what? Behaviors. Okay, so state is done, behavior is done. Okay, now let's look at identity. Okay, so identity, see, look at this line here, okay, I am creating an object. Okay, an object by the name of Ankit. Okay, and Ankit is an object of which class? Student class. Okay, Ankit is an object of the student class. What do I mean by this? Just like hammer 1. Okay, just like hammer 1. Okay, hammer 1 is an object of the hammer class. Okay, hammer class. This is our hammer 1. This is our hammer 1. Hammer 1 is an object belonging to the hammer class. Similarly, Ankit is an object. Ankit, okay, Ankit is an object belonging to the student class, right? So once I have created an object, okay, by the name Ankit, this name can be anything. So that is known as what? That is known as identity, okay, identity, giving a name to your object, okay. Okay, now finally let's see state, okay, state. You know what are attributes, right? When you assign values, okay, like a and 15, you are assigning a to section, okay, and you are assigning age of 15 to age, okay. So Ankit's section is a and Ankit's age is 15, okay. That means now you have associated values with the attributes. So the attribute has become state now, okay. In other words, state is associated with the actual object, okay. So state is associated with the actual object, that is Ankit, okay. So state, okay, this is the state value of a and 15 being assigned to section and age, okay. This is what? This is state, okay. And you can say that the attribute is something which belongs to the class. It's the general specification that will be followed by all the objects of a particular class, okay. So let's say I create another student. I'll create another student, let's say by the name of Ankita, okay. So now I have two objects of the student class, right? One is Ankit and one is Ankita. We have already defined Ankit's section and Ankit's age. Okay. Now we can similarly define the section and age of Ankita as well. Okay. So as soon as you create an Ankita object, okay, its Ankita's state will come into existence, okay. Ankita will have certain section and Ankita will have certain age, okay. But the specification, the class itself, okay, the class itself, will have no the class, the attribute which is placed in the class will not have any values. It is just a template that has to be followed by all the objects of the class, okay. So I hope this point is clear. If you have any doubt, you can ask me, okay. Okay, so we'll stop here for today's. Thank you, students.